don't? That'd be interesting to check out. Oh shoot, you guys, I forgot my big deal theorem over there. So, let's finally come back now that we have the machinery, and let's talk about what would happen if this characteristic equation let's choose distinct non-real solutions. And if it does, I think they're going to look like this. Y1 is going to be nothing more than e to the, gosh, what does standard complex number look like? Would that be an alpha plus beta ix? And Y2 will look like, you like gammas and deltas? What would you like?
Gamma.
Someone said alpha. Where'd you get alpha? Anybody want to see? You pre-calculus experts? These coefficients are real numbers, and I get a non-real complex solution to such a polynomial equation. You know.
Alpha minus beta
Thank you.
times I.
That the non-real solution are going to come in complex conjugate pairs. Are we there?
Too much magic.
Too much magic. Or in other words, I got e to the alpha x times e to the beta I times x. And over here, I've got e to the alpha x times e to the negative beta ix.
Only if Wilson could calculate this stuff.
What's that?
Only if Wilson could calculate this.
But see, I think I'm going to do something more important. Instead of just
Okay.
calculating, I think I'm going to generate what my solutions must look like for the DE. So you guys look at play. Using Euler's identity, doesn't that give me this? And over here, doesn't it give me this? Oh, you guys, I don't like minus signs. Can I get rid of them real quick? Actually, the cosine function is nothing more than an even function, so the cosine of negative beta x is the sine thing as the cosine of beta x. However, the sine function is an odd function, so I think another name for the sine of negative beta x is a negative sine beta x. At a glance, do you think these are two linearly independent solutions? Do you think one's a multiple of the other? No. I don't either. I think they're linearly independent. So I can now proclaim that the solutions to my DE are going to be of this form. I don't want to. I don't want to because these are non-real functions. And so if you guys don't mind, I'm going to do this. It's a second order DE. I need two linearly independent solutions to generate all my solutions. But like with any vector space, all I need is any two linearly independent elements of my vector space, and all linear combinations are going to generate everything in the vector space. I just need two linearly independent solutions to generate the solution space. So check out if I choose this one. Let y sub 3 be equal to y1 plus y2 all over 2. If I do, then when I add this solution to this solution, doesn't the I term cancel out? And I'm merely left with 2 times e to the ax, or e to the alpha x, times the cosine of x, all over 2. Well, now the 2's are going to cancel, and I'm merely left with y sub b3 being equal to e to the alpha x, times the cosine of beta x. However, if I allow y sub 4 to be, how about the difference between those two solutions? All divided by, how about 2i? Check out what happens. Now when I take this y1, subtract from this y2, now the cosine terms drop out. And I'm left with 2 times I times e to the alpha x times the sine of beta x all divided by 2I. Now the 2's and the i's cancel, and I'm merely left with e to the alpha x times the sine of beta x. Shoot. Those are clearly two linearly independent solutions to my second order DE, so I think all solutions are of the following form. Y of x being equal to e to the alpha x times c1 cosine beta x plus c2 times the sine of beta x. Man, I just did a lot. I derived what all such solutions must look like for that second order DE. Chris?
Are those two vectors orthogonal?
Depends on how you define your inner product. It would depend on how you define that.
Whoa, wait a second.
Yes, always.
I guess this is back to chapter 4, but, so vectors can be orthogonal or not orthogonal depending on the definition of the inner product.
Absolutely. That means when you used the Gram-Schmidt procedure, how you generated that, or how you forced that orthogonality, really did depend on how that inner product was defined.
So there isn't a unique orthogonality principle?
No, although I have to confess, with some of my vector spaces, I have come to class and said, can we consider the natural inner product defined in this vector space?
Okay.
But certainly not a unique one. Oh, you guys, we have 10 minutes. All this theory that I just gave you, within 2 days, you're not even going to be thinking about it. You're just going to be automatically solving your differential equations. Now that I got my 3-case scenarios, let's take a peek at some examples. Oh, positive
3x plus x e to the 3x.
Very nice. Are you there? Anybody? So, is this going to give me e to the negative 1/2 x times c1 times the cosine of is that a root 3 over 2x? Why do I feel so alone again? You guys are pretty.
Question.
Yes, Chris.
Isn't there a theorem where if you have CIS of r times theta, then you can take the r and make it CIS of theta exponentiated to r?
Say that again. Maybe I'm just too tired, Chris. Say that again. If you had e to the
Oh, I don't have any e's, but if you have cosine of, or CIS of r theta,
gotcha.
then that should be CIS of theta to the r power times r, I think, maybe? I'm not sure. I can't remember. There's something like that along those lines. I'll look it up and I'll come back to you.
Yeah, look it up.
But I just want to
make
take the root 3 over 2 out of, you know,
I see. I see.
it's not important.
And I necessarily don't want to pull it out. I think it's inherent to the type of solutions I have to this DE.
I'm just not seeing where the root 3 over 2.
Well, I was looking at the corresponding auxiliary or characteristic equation, which is this. And in my head, I was just using the quadratic formula.
huh?
How did you get in the first example, where are the threes coming from?
When I listed the characteristic equation in my head, I was getting this. Got my heart value. It's just a math issue. It's just math. It's so nice you guys aren't throwing things at me when I say that. Oh, you guys, my examples are two. They're two. Yeah. So, part 3.
Isn't class over?
5 minutes. One more example. One more.
Okay.
What would the auxiliary equation look like for this?
And with this equation, here's a corresponding auxiliary characteristic equation. You know, one of those easy equations to solve. You guys are killing me. Rational root theorem. So let's try a little bit of synthetic division. I'll list my coefficients. I'll put in I'll just try one. Drop, multiply, add, multiply, oh, look at that. Piece of cake. And now I maintain that this polynomial expression can be factored into an r minus 1 and an r squared plus 7r plus 4. Now, if I use a quadratic formula on a quadratic equation, wouldn't I get my negative b plus or minus the square root of b squared minus 4ac all over 2a? But that simply means that all my solutions to my third order differential equation is going to involve a linear combination of 3 linearly independent solutions. I think they're going to look like a C1, is that an e to the x plus.
Isn't it 2r squared?
You guys, I did something horrible wrong with my math D, didn't I? Don't we just drop? And I must have done it right in my head because I multiplied correctly. Sorry. So I think I get C1 e to the x plus.
Does that change our 16 to something else?
Yeah.
Oh, it certainly does. Thank you. Vince. Anybody? Really? All right, with the arithmetic, don't you guys agree, just numerically speaking, this is nearly a negative 7/4 plus or minus something over 4. Egads, what's that something going to be? Anybody? I'm sorry, I'm so slow.
It would be
I agree
root.
with 17.
Yeah.
So I think my second linear independent solution, C2 times e to the,
Negative 7/4.
you guys, piece of cake, isn't it? Mike?
For the quadratic formula, next to the 4,
Yeah, what the
the first part of the thing of the square root, is that another 4 or is that a?
That was my 7 squared.
7? Okay.
Anybody else want to shake me up on this? Okay. If not,
Wouldn't you have to have a multiple of x in those terms?
oh, you mean down below?
Yeah.
I would only have that if I am only generated one solution to say a second order DP.
Okay.
Then it's sort of like I put an x e to that power just to force the linear independence of those two solutions.
Okay.
Mark, may I again? For you guys to get some practice, take a peek at the following. Daniel, before you leave, can we just check my email real quick? I can do it on this computer.
Yeah, one on that.
Oh, you guys, we finally got back to DEs. In section 6.1, can you look at 1 through 39 odd?
What section is it?
6.1. Oh, by the way, you guys, I'm not done. So can you take a peek in section 6.2? Can you look at one through 37 on? Let me know how to go.
You did get a tone for 5.